This video is going to take you through some concepts for your midterm review. So we're going to start with chapter 1 and all the information that you need to know for chapter 1, and then I'll let you know which problems from your packet you would coincide with those sections so that you can work on them. What I want you to do is take notes on what we talk about today, and then you'll submit the notes at the end of the video so that you can get credit for a classwork assignment. So we'll start with chapter 1, which was the introduction to a lot of the segments and that kind of stuff, angles inside geometry. So in 1.2, you started to identify the length of a segment. So if I gave you a number line and I numbered it like -3, -2, -1, 0, 1, and 2, and I put a point A here and a point B here, and I just asked you to find the length of AB. So you can either do B minus A, or you can count from 1, 2, 3, one to the other, and I would get AB is 3. Again, I could have done the actual point of B, which is 1, minus A, which is -2, and I would have gotten the same thing. And then it would say something like A is between B and C, and you'd get a diagram. So B, A, C, and something like 2x plus 1 and 6, and it would give you the information that BC equals (23), and then you would use your segment addition postulate to say that 2x plus 1 plus 6 would equal 23. Combine your like terms, subtract the 7, and then divide by 2, and x would be 8. And then it would either say, identify what x is, or maybe find the length of AB. So if it asked you to find AB, you would have to take B and plug it back in. So take 8 and plug it back in. 2 times 8 plus 1, or 16 plus 1, which would be 17. And then also in 1.2, you got introduced into a midpoint. Which is the point halfway between two other points. So if I had used the same example from before, but instead of saying that A was between B and C, I said something like A is the midpoint of BC, and I gave the same segment. So 2x plus 1 and 6. This is B, this is A, this is C. This time I would know that A is halfway between B and C. So these two would be congruent, and I would say 2x plus 1 equals 6. 2x would equal 5, and x would equal 5 over 2, which is 2.5, or 2.5. And then it probably won't ask you for the length of the segment, because if you did, you would just take it and plug it back in. So if that was the case, you would see variables on both sides. So in this case, it could either ask you for the x, or it could ask you to find the length of the segments here. But if that was the case, you would see variables on both sides, which is kind of like number 3 in your packet. Okay, 1.3 was your introduction into angles. So we talked about the parts of an angle. If I drew an angle and labeled it A, B, C. The sides are rays. So in this case, the sides would be ray BA and ray BC. And then the point where they meet is called the vertex. So the vertex of this one would be B. And then in this case, there's two ways to name this angle. I could either call it angle B or I could call it angle ABC. Because that vertex only has one angle attached to it, you can actually use both. If I had drawn another segment in here, let's say this is a ray BD, now I can no longer use angle B as its name. I would have to use 3 letters. So if I was describing the big angle, I'd have to call it ABC. If I was referring to the top angle, it would be ABD. And if I was referring to the bottom angle, it'd be DBC. So as soon as that vertex is shared by more than one angle, you can no longer use those 3 letters. You have to, you can no longer use the single letter. You'd have to use the 3. You also learn to classify angles in this section. And this is just a snapshot of your book. So there's 4 different types of angles: acute angles, which are less than 90, right angles, which equal 90, obtuse angles, which are greater than 90 but less than 180, and then a straight angle that would form the line, or the line formed by 2 opposite rays. Also in this section was your angle addition postulate. Which comes from if you have a point in the interior. So if I said this was, again, A, B, C, and D. So D is my point in the interior of angle A, B, C. Then I can say that angle A, B, C is equal to the sum of the smaller 2. So angle A, B, D plus angle D, B, C. So I don't know that those are equal. I'm not saying it's the bisector of the angle, but you are saying that the larger angle is the sum of its 2 smaller parts. So you'll see that applied, maybe it'll say something like, you have this angle, and it says that this angle is 25 degrees, and this angle is 30 degrees. What's the sum of the big angles? So you can add those together to get the 55 degrees. Or it would say something like the large angle, so the big angle is 70 degrees, and one of the smaller angles is 20 degrees. Find the measure of the other angle, and this time you would subtract. So you take the big angle and subtract the smaller angle from it to get the missing angle. You'll also see this with variables, and that's like number 5 in your packet. Okay, and then in 1.4, we were introduced into pairs of angles. So you saw linear pairs, which are 2 angles that form a line. So something like angle 1 and angle 2 would be a linear pair. And then we later learned that those would add up to 180. We learned about complements, which are 2 angles that sum to 90. And we learned about supplements, which are 2 angles that sum to 180. So we later learned that linear pairs are supplements because there are 2 angles that would sum to 180 degrees. So you'll see those in a couple of different ways. It might say like the measure of an angle is 60 degrees, find the measure of its complement, and so you would do 90 minus 60 to get 30. Or it would say 2 angles are supplementary and 1 angle is 130 degrees. What's the measure of its supplement? So you would do 180 minus 130, that kind of thing. And then you'll even see where it says something like, find the measure of the supplement of angle A given angle A equals 4x plus 30. And so for something like that, I know if there's supplements, they'd add up to 180 degrees. So this angle plus the angle that we don't know would equal 180 degrees. Since we can't introduce a new variable here, I would say that the remaining angle would be 180 degrees minus the current angle, so 4x plus 30. And then I would just distribute the negative, so I'd get minus 4x minus 30, and then combine your like terms. So you'd get 150 minus 4x. And then you'll also see, which is a great standardized test question, an angle is twice its supplement. And then in 1.5, we started to review perimeter and area. And the first three were the three basic shapes. Which are the rectangle, the square, and the triangle. So the perimeter of a rectangle would be twice the length plus twice the width. And the area of the rectangle would be length times width. The perimeter of a square, because all four sides are the same, would be 4 times the length of a side. And the area, because length and width are the same, would be side squared. And then you did triangles, which the perimeter, you have to add up all the sides, A plus B plus C in this case. And then the area of the triangle, which is 1/2 base times height. And the important part here is that your height is that perpendicular line that runs up and down the middle of your triangle, which we now know is called the altitude. And then we did circles. So a couple of parts to the circle, straight from the center to the side. This was called the radius. And then all the way through would have been the diameter. And the perimeter of a circle is actually called circumference. This is like the crust of the pizza. And to find that, it is pi times d or 2 pi r, because those are the same thing. 2 times r would give you d, which is your diameter. And then the area of a circle, which is pi r squared. So those match questions number 8, 9, and 10. Again, I'll write that at the end from your packet. And then the last section in 1.6 was your midpoint and distance formulas, and Pythagorean Theorem. So 3 formulas here. The first is the midpoint. To find the midpoint of a segment when you're given 2 endpoints, you would add the endpoint of 1, so x1 plus x2 and divide it by 2, and then y1 plus y2 and divide it by 2. So again, that's if you're given 2 points like x1, y1, and x2, y2. So if I had something like 2, 3, and -5, 6, then I would add my 2 x's together, 2 plus -5, and divide by 2, and then add my 2 y's, 3 plus 6, and divide by 2. So I'd get -3/2 and 9/2. And if you could simplify it, you would. And then if not, you can leave it actually as a mixed fraction. So that would be -1 1/2 and 4 1/2. Which is, so on your test, they'll either be whole numbers or you'll see it as mixed fractions. And then the second formula is the distance formula. And again, this would be between two coordinate points. So if you got two endpoints, like the same thing like 2 and 3 and -5 and 6, and it asks you to find the distance between them or the length of the segment that connects them. And the formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So if I was finding the distance between these 2 points, it doesn't matter which one you make your x1 and your y1 and your x2 and your y2, as long as you're consistent. So as long as the first set of parentheses has both the same number and so does the second set. So now I'm going to plug them into this equation. So I end up with the square root of x2, which is -5, minus x1, which is 2, squared, plus y2, which is 6, minus y1, which is 3, squared. And I get the square root of -7 squared plus 3 squared, or the square root of 49 plus 9, which is the square root of 58. And then you're going to leave this as a simplified square root, which means I have to see if that can break down at all into its factor tree. So 58 would be 2 and 29, and 29 is prime, so it stops there, and I would leave square root 58 by itself. Let's just say it's something like the square root of 80. Then I would break that down so that it would be 2 and 40 and 2 and 20 and 2 and 10 and 2 and 5. And then for each pair of 2's, 1 2 goes to the outside because it would be 2 times 2, a square root of that would just be 2. So 2 2's brings 1 2 to the outside. A second pair of 2's brings the second 2 to the outside. And then the 5 that doesn't have a match would stay underneath. And then you'd multiply together what's on the outside, so this would be 4 root 5. So if it can be simplified, it needs to. In this case, it can't, so I can keep it that way. So the distance formula is one way to find the distance between 2 points, or the length of a segment that would connect those 2 points. The other way to do it is the Pythagorean Theorem. So for this one, I'm going to bring in a coordinate grid. And I'm going to plot my points. So 2, 3 is here. I'm going to do that a different color. 2, 3 is here. And -5, 6 is here. And I want to make a right triangle out of them. So I can either go down and to the right, or I could have gone to the right and down. It doesn't matter. And then I want to connect those two. This is what I'm trying to find. So the Pythagorean Theorem is a squared plus b squared equals c squared. It's probably one of the most important formulas that you learn in geometry. And the important part about c is that it's the hypotenuse, or the side, the longest side, the side that's going to be opposite your right angle. So this is c, and that's what we're going to try to find. The other two, a and b, are interchangeable. So you could keep them like that, or you could have switched those values, and it wouldn't matter. So I'm going to make a the vertical side here, which is 1, 2, 3. So 3 squared. And then b would be the horizontal, 1, 2, 3, 4, 5, 6, 7. Distance from -5 to 2 would be 7. So 3 squared plus 7 squared would be 9 plus 49, which is 58. That equals c squared. And then I would square root both sides, and c would equal the square root of 58, which we already know can't be broken down. So that would be the distance between those 2 points. So on your test, it's the same question, and it just says use the distance formula and the Pythagorean theorem to find the distance. You can use one to check the other. You don't have to use both, and if you're more comfortable with one, then you can stick to it. But you're definitely going to see them both separately again throughout the rest of the book. Okay, so that's all the information that you need to know for Chapter 1. So you're going to spend the rest of the time working on the problems from the packet that are dealing with chapter 1. So if you want to mark them down, if you want to go through 1.2, you'll find numbers 1, 2, and 3 are from this section, which was your segments, your segment addition postulate, and your angles, or not even angles, just segment addition postulate, and midpoint. 1.3 was numbers 4 and 5. And those were your angles. So that was your angle addition postulate. And then, that was just the angle addition postulate, or classifying an angle. 1.4 are numbers 6, 7, and 34. This is your complements, your supplements, your linear pair. 1.5 are numbers 8, 9, and 10. That was your perimeter and area. And 1.6 are numbers 11, 12, and 13. So those parts of your packet are from chapter 1. That's what you want to spend the rest of the class working on. And then also don't forget that you need to submit your notes before you leave the classroom. And then you can continue to work on the packet as much as you can, but we'll also do a video for the remaining chapters 2, 3, 4, and 5.